All right, so your 5 ways. Okay, remember you've got side, side, side. Now again, we're looking at congruency, not similarity. So this is where the sides needed to be congruent to each other, not in proportion. Then you had side, angle, side, right? Then there were the 2 of them that had 2 angles in the side. You had the angle, side, angle. You had angle, angle, side. And like I said, last but not least, you had the one that was specifically for right triangles, which was the HL. In terms of like you guys writing proofs, this doesn't necessarily just pertain to triangle proofs. And I know a lot of the things you guys will see, even on the EOC, are going to be fill in the blanks, but you still need to know the process to how to write these from scratch. Because the ones I'll give you guys, they're not all going to be fill in the blank. A lot of the ones in the book will, but the ones I give you specifically will not be. So in terms of any kind of proof you're writing, you're going to have some kind of diagram there. Even when we did the parallel line stuff, you guys still had a diagram. Your first thing should be, if the picture does not already have them marked off, go ahead and mark all the givens. Like if they tell you 2 lines are congruent, put congruent marks on those lines. If they tell you lines are parallel, put the parallel marks on them. Congruent angles, so on. Okay? Because that's your starting point. There's going to be a few of these where if you mark all the givens, it's already going to match up to one of the theorems, so you're technically not writing anything additional. It's just a matter of I see the givens. They gave me 3 side lengths that were congruent, so I'm putting side, side, side. Probably not going to happen, but it might. Second thing is, back in the last section, when we did this to start with, like the first day we brought up all the different ways to show triangles are congruent. We started writing out the common figures. This was like me saying, if you see a picture that has vertical angles, you mark the vertical angles congruent. The reflexive property. Right angles being congruent. You might have had something with midpoints in there. Parallel lines being alternate interior angles. Okay, so on. Because essentially, if you mark your givens and then you just use the picture for the rest of it, chances are you're going to have enough marked on those pictures to show that the 2 triangles are congruent to each other. Okay, so again, like this step here is looking for things like vertical angles. So if you need to make a note next to this, what I mean by this, this is meaning find the vertical angles, find like a reflexive side, find the alternate interior angles if you've got parallel lines. If you've got a bisector, mark off the segment that's split in half, that kind of stuff. Because essentially what will happen is after you get through 1 and 2, so 1 is mark the givens, 2 is basically just screw with the picture until you see everything marked congruent that you need. You're going to have one of those things pop up. Now again, like I include HL there because it's a viable option, but you have to have the right angle. Just because there's a right angle there doesn't mean it's HL. It's possible. Then once you're done with that, then I would suggest then you would take everything that you worked with and throw it into a proof. Obviously, if this is like a fill in the blank one, this step is kind of already done for you. But if you're writing this from scratch, all of this stuff up here should be you just messing with the picture. Because anything that you mark on the picture needs to translate to a step in the proof. So if you mark vertical angles, that will become a step in the proof. Let me, again, like I said, I'm going to talk through this as if nothing's marked. I'm going to go through the steps that I would suggest you go through on all these proofs. So step 1 would be you take whatever's given and mark it off. I understand it's already on there, but just for the sake of saying it's not, or for the process, I'm going to add my own little marks there, just going over what's there. So that's like step 1. And in general, if you're writing this from scratch, I would also suggest numbering everything you draw on the picture to just kind of remind yourself that it has to transfer to a step when you write it out in your columns. So that's all the givens. So then you're done with step 1. The second step is going to be try and figure out anything additional you can add strictly based on the picture. So the vertical angles, reflexive, parallel lines, so on. I got vertical angles there. So that's the second thing I marked on there. I'm good to go. Now, you guys already told me it was side angle side, yes? Okay, so I already have enough to do this part. So this is going to end up being 1, 2, 3 steps because I've got side angle side. So it's a fairly short proof. But again, like writing all over this and giving yourself number guidelines and stuff will help you at least determine how big to write this out. I'm going to try and fit it over here. Okay, so when I write out my proof, you always start with your givens. That's what I put the number 1 on. So BC, DC, AC, and EC are all congruent. If you guys are writing this, you can always throw as many givens together as you want, which you might see on some of the fill-in-the-blank ones as they'll split them up. It's not necessary, but it's fine if you want to. Second thing is the vertical angles. So that was BCA is congruent to ECD. Okay, reasoning will always be the ones that we listed for common. Like this is vertical angles. If I had reflexive, you put reflexive there. If they're alternate interior angles, so put that there also. All right, and then third step would be rewriting whatever you're trying to prove because we got to the point of saying that we had enough to say the two triangles were congruent. And that's side angle side. Okay, so with this one, going through the steps again, for the first thing here where generally I say mark the givens, it's kind of hard to necessarily mark the givens on here because they're giving you the fact that this thing bisects the two angles. They're not specifically saying anything is congruent, they're giving you a word to use. So if they're giving you like a word to use, you can, if you want to mark the given, just give yourself like a word up there just to remind you, hey, that is the given. It's the fact that thing is going to be bisected. Now, there is going to be congruency based on that, but that has to be like an extra step. Your given is simply the word, not the property that goes along with the word. So it splits into 2 steps when you write a proof out. Okay, now look, since this segment in here is splitting this angle in half, ABC, and it's splitting that one in half, you're going to get that angle cut into 2 equal parts. You're going to get that one cut into 2 equal parts. Okay? Now, with a problem like this, if you were writing this from scratch, there are people that get the reason these two are congruent. They understand that angles are congruent, but they skip the step of actually writing out these two are congruent. Like my first step is going to be writing the given. My second one is going to be actually saying that those angles are congruent. So this is why I was getting at. If you draw something on the picture, it has to translate to a step.
Can I please have Patricia for dismissal?
Yep. Yeah, jeez, so nosy. Okay, then my next step would be that I've used the givens, right? The given was bisect. I used the word to create my angles that were congruent. Now I've got to mark my additional stuff. So what else is equal up there based on what the picture looks like?
Ooh, angles A and C.
That's right. What? So BD equals BD. I got the reflexive side. Okay? So that's going to be my third thing. So this is where I was saying look for the common properties because vertical angles or reflexive sides come up a lot. So where I'm at right now is I've got 2 angles and a side. That should give me enough to prove that the triangles are congruent. And this is angle side angle, so this is going to be my 4th step. So then it's just a matter of, look, again, a lot of people can do that part or at least partially that, but it's like translating it into the columns where sometimes people flip out. Okay? But if you kept it organized over there, it shouldn't be a huge deal. So my first thing is going to be the given, so I'm going to restate that. So BD bisects, was it ABC and ADC? Okay? Second thing is going to be I'm actually writing out the congruent angles. So not just, this didn't give me congruent angles, this just gave me a word to use. So again, this step gets skipped a lot. but I actually need to state that ABD is congruent to CBD and the ADB is congruent to CDB. Right? Now, my reasoning for that is this word right here, the bisect. So you can just put its definition of a bisector. It's an angle bisector technically, but it doesn't matter. If you at least acknowledge the fact that bisecting means it cuts it into two equal parts, something of that manner right here, you should be okay. All right, third thing was the reflexive. So the dB is congruent to dB. And then that was enough for us to say the two triangles were congruent, and that was what, ABD. And that was angle side angle. Next thing that you need to add is going with like a basic idea of what the definition of congruency is. Now the thing that's up here right now says if you know two triangles are congruent, then all the corresponding parts have to be congruent. Where this idea gets used in proofs would be, let's say I had that exact same picture, the exact same given, but instead of asking you to prove that the two triangles are congruent, you might see something that says prove AD is congruent to CD. So I still have the same triangles, I still have the same givens, I can still go through the work to find the triangles are congruent. But what this is stating is the fact that if you know that the two triangles are congruent, you can then go on and show that all the congruent parts are also going to be equal to each other, or the same. But if I did have that as a proved statement over there, like all of this would be identical. Okay, all that would happen is you're adding one more step that says those two corresponding parts are congruent to each other. The reason for that is you either need to write out in words the corresponding parts are congruent, or what you might see on a lot of these tests is that abbreviation right there, the CPCTC. Okay, which stands for corresponding parts of congruent triangles are congruent. You can either write, if you're writing this out by hand, you can either write that abbreviation out, or you can just say the corresponding parts are congruent. Okay, now look, this only comes up, this part right here only comes up if you see two triangles. Like if in your picture you can decisively see two triangles, and they're asking you to basically prove something other than these two triangles are congruent. Chances are from here on out, if we're doing a proof and there's triangles in it, you're going to prove that they're congruent and then utilize that in some manner. Okay, so again, I'm going to go through this step by step just like we do the other ones. Okay, meaning that first step should always be mark the givens. Again, I know the picture has it, but I'm still going to remark it anyway. So the two givens are they got the two sides being congruent and two sides being parallel. Okay, so I know that's my first step. Hey, if you saw this one and it was a fill in the blank, they're probably going to have those two givens split. If you ever see givens split, it's just because they don't like relate to each other. So if you use one to find something else, they'll split it out. But generally speaking, I don't really care if you do that or not. All right, second thing will be, I'm going to mark all the stuff that can be additional based on either what's given or what the picture is. Meaning that I've got a side that's reflexive here, so I can mark that congruent to itself. If you guys have parallel lines given to you, you need to find the alternate interior angles, because those alternate interior angles will always be congruent to each other. And like 99% of the time, if they give you parallel lines, you're marking alternate interior angles. The only time you would not mark alternate interior angles is if you had a picture like this, and those were the parallel lines. Because you don't have alternate interior angles there. Every other time you will. Okay? Where are you going to? No. Don't, if you're doing these, don't bring that word up unless it says it. Okay? Like, don't add it unless it actually says it in the given. Don't do it, because it's going to throw you down the path that is not going to be correct. Okay? All right, so here's the thing. With these alternate interior angles, these things have to touch the parallel lines. Okay? So if I've got parallel lines here and here, my alternate interior angles have to be there and there. All right, and that's going to be it. So those are the only ones that fit the definition of alternate angles, but also in contact with the parallel lines. So that's the third thing. So then where I'm at right now, I can say that these two triangles are congruent, which is good because, again, I want to, because like I said, majority of the time, if you see triangles in the picture, you're going to want to say they're congruent to each other. And I know they're congruent because I've got one side, I got an angle, I got another side. So my fourth step is going to be using side angle side to say that they're congruent. And then as soon as I say they're congruent, I can match up all the missing corresponding parts and say that they're automatically equal to each other, which is what you're doing with that fifth step. So it's like 5 steps. Yeah.
The angle NT and NT2, they're alternate interior too, right?
Wait, which one?
The one, the other M, like the left side of the M, and then the E.
This one?
Yeah.
They are, but because I can't say that these are congruent because these lines aren't parallel. Like, based on what's given, there's nothing saying this line doesn't go all the way out here if it's not drawn to scale. So the reason you have to connect it to the parallels because that's the thing that's making the size the same. So, like, in the end, like, once I'm here, yeah, it does end up that they're congruent to each other, but that's, like, after the fact. You can't use that to actually get to where you need to be. Okay, so if I organize this thing into a proof, it's going to look like all my givens first. Which again, if you want to split those up, you can. The second thing that I marked on there was the reflexive side. Okay, so the MT and MT were congruent. Third thing was the alternate interior angles, which are QMT and MTN. Okay, fourth thing we said that as soon as I had all this, I have enough to say that the two triangles are congruent. So it'd be triangle QMT and triangle QMT NTM. Side angle side. And then the fifth step would be adding in the fact that those two sides correspond to each other. So since they're corresponding sides, and I know the triangles are congruent, they have to be equal. So you can either write the abbreviation, or you can just write like corresponding parts are congruent.